Hi everyone, here's the second part of our chapter 16 homework. So we learned from 1 to 5 how to find out the rate orders, right? Orders of the reactants. Now number 6 is similar to number 5. So you saw how number 5 worked and you can do the same thing for number 6. Okay. Rates are given, initial concentrations of A and B given. So follow the same procedure. You should be able to find the answer for number 6. And number 7 also similar. And here we have 3 reactants. So you have to do it 3 sets. So again for this one, which is similar to 5, we did, you can do your rate. So you can write the rate like rate equals K A raised to the power M, B raised to the power N, and C you can consider maybe as P. So you have to find M, N and P values or the orders. So to find the A, what you can do is you're going to look up what are the reactions where B and C remain constant. So here B constant, C concentrations constant. So to find the A, you can use the first two reactions, 2 over 1, rate 2 over rate 1. Okay, to find the A, you can use rate 2 over rate 1. So rate 2 is 0.0439, you divide by 0.0217, and similarly 0.330 divided by 0.225, so you can find out the M. And if the M or the order is not obvious, you can also use the log term, right? Log term to find it out. So basically, if you have A equals B raised to the power M, you can find out M equals log A over log B. Okay, and that is to find the A. Now what about B? What two things can we use to find B? Order of B. So maybe you can use where 1 and 3. You see, concentration of A constant, C constant, C constant. But for the B, 0.150, 0.250. So you can use these two rate data, the blue ones. So you can do rate 3 over rate 1. Rate 3 over rate 1 to find out the order with respect to B. Okay, and for C, what can we use for C? So to find out the C, you can use where we need to have C changing, but we want to make sure A and B constants. A 225, B same, but the C is different. So you're going to be using rate 4 over rate 1, 0.6 over 0.35, 0.001270 over 0.027. Okay, and from that you can find out the order for C. Remember, order can be a full number, whole number, it could be a fraction, it could also be a negative number, or it could also be a decimal one, right? So make sure that you can consider negative orders as well. Okay, so you can find A, B and C based on the same method we use for 5 and 6. Okay, number 8. Sulfonyl chloride decompose, rate constant at a certain temperature is given. What is the order of the reaction? Now you are given a rate constant, and that is this over here. What is the order? If the rate constant is given, you can find out the order by looking at the unit. It says per second. So to find out, so you might not remember what are the units for each and every order of a reaction. You can refer to our lecture notes where we have this table. For a zero order reaction, units are given. Okay, so for a zero order reaction, units are given, and for a first order reaction also we are given. Let's do this. Okay, all right. So for a zero order reaction, these are the units, and for a first order reaction, 1 over S O per second. For a second order reaction, these are the units. For a third order reaction, these are the units. So since we are only given the rate constant with the units, that unit represent for a first order reaction. So by looking at that, you can directly get the answer that it is a, what is the order of the reaction. Okay. And then the number 9. Which of the following sets of unit could be appropriate for a zero order rate constant? Again, you refer to the same table that I just showed you and find out what are the units for a zero order reaction. Number 10, which of the following for a second order rate constant? Again, you refer to that table and figure out what is the units for a second order reaction. Number 11, reaction has the following rate law. Okay, so we are given the orders. Rate is given as A, B, second order. A first order, B second order. In experiment 1, the concentration of A and B are both 0.1. Experiment 2, the concentrations are both 0.3. If the temperature stays constant, what is the value of the ratio rate 2 over rate 1? So how do we do that? Again, this is not that hard. So rate 2 over rate 1. Rate 2 over rate 1. So the rate is given to us as this. So we have the constant K and then A. Concentration of A for the second reaction. In experiment 2, the concentration are both 0.3. So A is 0.3, B also 0.3. You write it down. And order with respect to A is 1, order with respect to B is 2. You divide it by K, rate constant, and for the rate 1, concentration of A and B both for the first experiment 0.1. So 0.1, 0.1 raised to the power 2. So you just have to solve this part. So basically K to K cancelled. 0.3 raised to the power 3 over 0.1 raised to the power 3. So you solve it and you can find the answer, value of the ratio. Okay, so you guys can do that. Number 12, ammonium cyanide react to form urea. Okay, so meaning this is your reactant and this is your product. The rate constant K is given 3.60 with a certain number of kinds of units. What is the rate law for this reaction? How do you answer this one? Now it says, it doesn't tell us what is the order, but it gives us the units. Do you see that? It has given us the units. So the units are these values. So what you're going to do is you refer to the table and find out liters moles per second. What is the order that gives you these units? Okay, and then let's look at that. It's second order. You can just refer to the table and these are the units for the second order reaction. But you make sure you check that too. Okay, and we are given two formulas. First one is your reactant, the second one is your products. Normally we write the rate law for the reactants. Okay, so then the rate would be, rate constant K is 3.60 with the proper units, and since the units that is given is for the second order rate constant. So your answer would be 3.60 with the proper units, liters, moles per second, and the reactant NH4 CNO, since it's second order, this raised to the power 2. Okay, so the answer, you can find out what is the answer. Okay, you figure out. I almost gave you the answer, so you can choose which is the correct one from this 5. And then the next one, 2NOBr giving you 2NO and bromine. Based on the initial rate data, what is the value of the rate constant? So the rate constant, so normally rate is given like rate equals K, and the concentration NOBr here with the order like this, right? So we want to find out the rate constant K. To find out the rate constant K, we need to know the rate, and also we need to know the concentration, and we need to know the order of the reaction. So far we know the rate and concentration of NOBr, but we don't know the rate order of the reaction. So to find out the order, just like we did before for our previous experiments, we have to use 2 experiments and divide them to find out the rate order of the reaction with respect to NOBr. So let's try to do that. We can use any 2 of these. Let's do 1/2, these 2. Okay, rate 1 over rate 2. So K, and NOBr concentration for the rate 1, 0.0450 and 0.0310. That is the initial concentration. So K and K cancels, and 0.050 over 0.0310, you guys can do that calculation. Okay, so this is M, and rate 1 is 1.62 into 10 to the negative 3 over 7.69 into 10 to the negative 4. Okay, so 0.450 over 0.031, that would be 1.45. Do these calculations with your calculator and see the answers that I'm getting is same as what you guys are getting. Okay, and if there is any mistake, please feel free to let me know. So 1.62 over 7.69, 10 to the negative 4, that would come to be 2.10 from left side. 2.10 equals 1.45 m. Okay, so it's not obvious what is m going to be. So basically you can use the log. M equals log 2.10 over log 1.45. So log 2.10 is 0.322 and 0.161. 0.322 or 0.161 is 2. So order with respect to NOBr is 2. Now with that in mind, we can use this rate equals K NOBr. Now we found the order. So the rate constant K would be then rate over NOBr concentration 2. So you can use the rate, any of the rates. So if you use the first one, 1.62 into 10 to the negative 3. 1.62 into 10 to the negative 3 over concentration of NOBr, for that 0.045, and then we found the order as 2. So solve this math part. 1.62 into 10 to the negative 3 over 0.045 raised to the power 2 should give you K, rate constant. So you guys can find that out. Okay. Okay, number 14. A study of the decomposition reaction yield the following initial rate data. What is the rate constant for the reaction? And number 14 is pretty much similar to what we did in number 13. So you guys can do that too. And number 15, the reaction X goes to Y is first order overall and first order with respect to the reactant X. The result of doubling the initial concentration of X will be 2. So there are 5 choices given. Remember, we learned in our lecture that if you have a zero order reaction, nothing happened to the initial rate. Rate does not affect. If it is a zero order reaction, so by doubling the initial concentration, nothing happened to the rate. And if it is a first order reaction, doubling the concentration of A, which is initial concentration, rate will double. Okay, and if it is a second order reaction, if you double the initial concentration, rate would quadruple. Rate would quadruple. So with that in mind, you can answer question number 5. So that is the second part to homework 1. I will conclude this here, and I hope you understood how to answer these questions.